right? So what is the other application of critical section? The second application of critical section is order of execution. Order of execution. Which execution? Order of execution of the process. Order of execution of processes. So the processes, can we make an order of the execution of the processes with the help of semaphore? The answer is yes, we can do that. So we'll see something related to this. What is that? Order of execution. Okay. Let's see and find it out something related to this. Now, what is the meaning of order of execution? The order of execution means that if we have, let's say, n number of processes, can we make the order of that? Order of that means, let's say, we have three processes, P1, P2, P3. How many? We have three processes. Let's say we have P1, let's say we have P2, and let's say we have P3. We want to make the order in between P1, P2, and P3. Okay. Can we do that? Let's assume that we want to execute P2 first, and then we want to execute P1 first, and then we want to execute the next is P3. Now there may be the trick. Trick means one process output will be dependent on another process input. Let's assume that P1 is responsible for finding the radius of the circle. P2 is responsible for finding the area of the circle. And we have another process P3, which is responsible to finding out the cost of something related to the area of the circle. Okay. So let's say we are making a building in a circle form, and we want the process one is finding what is the radius. Process two will find the area of it, and based on the area, will decide the cost of the building. So what is the process? Okay. So the process is like this. Let's assume that. Okay, I have made it P1, P2, P3. I'll just do some modification here, and I'll do that. P2 is finding the radius, P1 is finding the area. So the execution will be P2 will execute first, then P1 will execute, and then P3 at last it is going to execute. So let's say this is my sequence. P2 will execute first, then P1 will execute, and then P3 will execute. So can we make P1, P2, and P3 in some order so that they can execute in this way? So with the help of semaphore, can we do? Yes, we can do with the help of semaphore. Let's say we are using a semaphore S1, and we are initializing with, let's say, 0. And in the system, we'll allow P1 to execute first. So we'll allow the P1 to execute first. Here, there will be no entry section for that. Means there is no wait method here. We'll allow P1 to execute. And then what we do is we'll make a signal. We'll call the signal. What signal will do? Signal will increment the value of S. In this case, it is S1. And it will become 1. Now, after P2, which process will be allowed? P1 will be allowed. So we'll make it wait S1. In this case, what will happen? In this case, what will happen? Because the value of S1 is 1, it can decrement the value of S1 by 0, and P1 will execute. And then P1 will execute and will make a signal. And will allow P3 to execute. So we'll have another semaphore, which is called S2, and we'll initialize S2 by 0. Because we have done the signal, S2 will become 1. Once S2 will become 1, we'll write wait here and we'll go for the calling the wait of S2. When we call the wait of S2, can we allow P3 to execute? Yes, P3 will be allowed to execute. Why? Because the S2 value is greater than 0. S2 value is greater than 0. What wait will do is, wait will decrement the value of S2 by 1 and allow into the P3. Now P3 will execute. So we got the order here that first which is going to execute. Now in this case, you can assume that we have initialized the value of S1 as 0, S2 as 0. Now this is the way how I have done the arrangement of P1, P2, and P3. Now, can we allow P1 to execute first in this particular phenomena? Now, if we allow P1 to execute first, it has to call wait first. Because it is calling wait with S1, S1 value is 0. So because the S1 value is not greater than 0, it will be in a busy wait and P1 will never get a chance to execute. What about P3? Can we allow P3 first? Because P3 is going for the value of S2 and it is calling the wait function for S2, and S2 value is 0, which is not greater than 0. So P3 is not going to execute and wait will be making this particular process in a busy way, and P3 will never get a chance to execute. Now you can see that in our system, P1 and P3 is not allowed to execute. Can P2 will be allowed? Because in P2, there is no precondition here. So P2 will be allowed. And once P2 will done its execution, there is a signal S1. So when we do signal S1, S1 will become 1. And then what process will be allowed? Can we allow P3? Now again, P3 will not be allowed because S2 value is 0. Can we allow P1? Yes, we can allow P1 because S1 value is 1 right now. And we can do the wait will not go to the busy wait. Instead, it will decrement the value of S1 by 0 and P1 will execute. Once the P1 will execute, it will make a signal to S1, and then because of the S2 value will become 1, P3 is going to execute. So you can see the sequence. Sequence is P2 will execute first. It will give the control to P1. Then P1 will execute and it will give the control to P3. So you can see this is how the control will go. And the order of execution will be there. So you can see with the help of semaphore, we can do that. So this is the second application of the semaphore, which is called order of execution. So can we make order of execution of n number of processes? Yes, we can make, but we required more than one semaphore to do that. So there might be the question like we have five number of processes, and let's assume that this is the sequence of execution, and the sequence of execution has been given, and you have to find out the way how they can do that, and you have to tell in the answer like how many number of semaphore is required for that particular order. So that type of question could be asked in the examination. So with the help of semaphore, we can do that. Okay, we can make the order of execution of the process. So I think you understood this. This is another application and a very good application of semaphore. Now let's see the third application of semaphore is resource management. Now, can a semaphore will do process management? Now, what is the meaning of process management? Sorry, what is the meaning of resource management? Now, we know that the resources may be anything. Resources may be a hardware, resources may be a variable, resources may be a CPU, resources may be memory, right? So, in the computer system, resources may be anything. Let's assume in this particular example, the resources is printer. And I have how many printer? Let's say assume that I have 5 printers. How many printers? 5 printers. I have 5 printers. How we can manage 5 printers? With the help of semaphore. Now, what is the typical way of the code of the critical section? Let's say we have a process PI. PI will use a loop, and inside the loop we have wait, in which will wait for the S, and then we'll go to the critical section, and then we'll do signal of S, and then we'll go to the exit section and the remainder of the section, and then done, right? Now in this particular thing, when we want to go to the critical section, we allow only one process to go to the critical section. Now you assume that this critical section part is nothing but the resources. Now in the example case, how many resources are there? I have 5 number of resources. How many? 5 number. So how many process I can allow into this particular part? So I can allow 5 number of processes in this particular part because I have 5 different printers. So I allow 5 processes to get the printer. Now for that, I'll make the S value as 5. Now what will happen here? When the S value is 5, can I allow process 1 to go to the critical section or to go into and get the printer? So yes, we can allow because S value is 5. 5 is greater than 0. So what wait will do is wait will decrement the value of S by 1. So it will become 4 and will allow P1 to go to the critical section. If P1 is in the critical section, can we allow P2 to go to the critical section? Yes, we can allow because the S value is 4 right now, which is greater than 0. And we'll allow P2 to go to the critical section by decrementing the value of S by 1. Can we allow P3 to go to the critical section? Yes, we can allow because the S value is greater than 0 and it will become 2 and will allow P3 to go to the critical section. Can we allow P4 to go to the critical section? Yes, we can allow because S value is 2 and which is greater than 0. It will decrement the value of S by 1 and will allow it. Can we allow P4 to go to the critical section? Yes, P4 will be allowed to go to the critical section because the S value is 1 right now, which is greater than 0. We decrement the value of S by 1, it will become 0 and will allow P5 to go to the critical section. Means these 5 processes are there because we have 5 printer. We'll allow 5 processes to go to the printer and use it. Can we allow P6 to go to the critical section? Now in this particular case, because S value is 0, it will be in a busy wait and P6 is never going to allow into the critical section. Why? Because no printer is free. 5 processes are there. 5 processes are using printers. So will not allow any other process to go and use the printer because printer is not free. If any of the processes will be done with the printer, it will execute the signal and it will become 1. Then only P6 will be allowed. So you can see how we can manage the resources with the help of semaphore. So we can manage the resources with the help of semaphore in this way. So I think you understood the three applications of semaphore. The first is the critical section solution. The second is the order of execution of the process. The third is resource management. So these three are the typical application of semaphore. Generally, we have two type of semaphore. One is called binary, which is also called mutex, and then we have integer. So we have binary semaphore and we have integer semaphore. When the value of s is 1 or 0, we'll use it for the critical section. So binary semaphore is used for the critical section problem solving, as well as we can use it for ordering also. But the integer semaphore is used for the resource management. So you can see we have two type of semaphore. One is called binary semaphore, another is called integer semaphore. So the binary semaphore is also called mutex, where the s value, the semaphore value, is either 0 or 1. Now in the integer semaphore, where the s value is an integer, that it will be used for the resource management generally. So that is all about your semaphore. So in the next class, we'll see some example related to the order of execution, and we'll see some example related to the resource management. Okay. And again, this is the topic of the semaphore that we are learning. After the semaphore, we'll go to the deadlock concept, and we'll see what do you mean by deadlock. In the deadlock, one process is waiting for another process to free the resources. So we'll see the problem of resource management here, and the problem of resource management is the deadlock, and that we'll see in the next few classes. The deadlock is a very essential concept of operating system. What happened is, sometime in the previous operating system, you find out the problem of hanging, right? Hang. So your system could be hanged. So what you have to do, you have to restart the system. So what is the meaning of hang? The meaning of hang is, if one process is getting the resource, another process is waiting for the same resource, but the process which are getting the resources are also waiting for the another resource. So we have a process, let's say P1, and P1 is holding one resource, let's say R1, and waiting for R2. Waiting for R2. In the same way, we have P2, which is having a resource R2 and waiting for R1 to be free. So in that particular case, what happened? P1 is waiting for, P2 is waiting for P1 to free the resource R1, and P1 is waiting for P2 to free the resource R2, and both are waiting for each other. That phenomena is called deadlock, and that we'll see in the next class.